What's up, scholars? Let's talk about some independent practice that a lot of us have been having some trouble with because it's a tough topic. It's a tough topic. We're going to go through the proofs from 4.4a in this video, and then I'll probably pause it and do 4.4b in another video. All right, so first we're going to look at IP skill 4.4a, identifying and building proofs using SSS, SAS, ASA, and SSS. I think we actually use side, angle, side for most of these proofs, but let's just see. Identifying angles with terminology, section 1 says which angle number represents the linear pair of angle MSN. Angle MS, there's SN, angle MSN, angle MSN is angle 6. MSN. Yep, that's angle 6. Linear pair means together they form a straight line. So that together, again, they form a straight line on the bottom, straight line on the bottom. So the number that represented the linear pair was this number here, which is 5. So MSN was 6. The linear pair is going to be answer 5. Submit. Yeah. Next question. If the measure of angle MSN is 106, what is MSP? That was the linear pair we just talked about. MSN, that's going to be 106 degrees. So MSP together with MSN, a linear pair means they're going to add up to 180. So this one is 106. This is the one we're looking for, and they're going to add up to be 180. So 106 plus X is going to equal 180. They make a straight line together. So we subtract 180 on both sides. Sorry, we subtract 106 on both sides and get a 74 degrees. So, yes, next question, annotate clear. The measure of angle DGA. DGA is way up here. DGA is angle 3. The measure of angle 3 is 130 degrees. What is GC? I said those backwards. CGB. CGB. Well, that's this one here, and these are vertical angles, so they are congruent to each other. So our answer should be 130 degrees. Submit. Okay. Yep. Next question. Which angle number represents the angle vertical to CHF? C to H to F. CHF looks like where that is angle 4. And the vertical angle is across from it, so that is the angle number 6. 6. Boom. Yes. And clear. And next question. The measure of angle DHE. D to H to E. DHE, that's angle 6 down here. That's 110 degrees. What is the measure of FHD? Well, that's this one here. Together, these guys form a straight line on the bottom. So that means they add up to a straight line, which is 180 degrees. So 110 plus X equals 180. Subtract 110 on both sides and get 70 degrees. X equals 70 degrees, which is FHD down there. Got it? Got it? Ooh, next section. Yay! Triangle congruence criteria. Determine the relationship between the two triangles and whether or not they can be proven congruent. Well, I see here marked angles that are congruent, angles that are congruent, angles that are congruent. So I would say I like to just mark up one of the triangles with the things that are marked congruent. So angle, angle, angle.
These are triangles related by angle, 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 which is not a way that you can prove triangles congruent. Angle, angle, angle does not work. And clear the screen. And the next question says, determine the relationship between the two triangles and whether or not they can be proven congruent. Well, let's just mark up the things that we have. We have a side marked congruent, an angle marked congruent, and a side marked congruent. So these are related by side, angle, side, side, angle, side. And that is a way you can prove triangles are congruent. Cool, cool. Clear this off. Ready, go. Next question. Clear this off. Yeah. Determine the relationship between the two triangles and whether or not they can be proven congruent. So let's mark up the things that we have. We've got a side congruent, an angle congruent, but the angle is not between the two sides. So this is a side, side angle, which is a backwards but, which is not something we can use to prove the triangles are congruent. All right. Cool, 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 cool beans. And I think we've got a couple more of these ones, right? Yeah, there's two more. Determine the relationship between the two triangles and whether or not they can be proven congruent. What do we have? We've got a side, we've got an angle, we've got a side. The angle is between the two sides, so this is a sassy triangle, and that is something we can use to prove that triangles are congruent. Yes. Okay, great. Next. What do we have going on here? This looks like a side and an angle and an angle, side, angle, angle, or angle, angle, side, which is something we can use to prove that triangles are congruent. Yay! All right, next section. Given segment AC and BC bisect each other. Now remember, that means they split each other in half. AC and BD split each other in half. We are going to try to prove that segment BC is congruent to segment AD. BC and AD, okay, got it. We're going to try to prove that these segments are congruent to each other. We are given that AC and BD bisect each other. So that means AC splits BD perfectly in half, which is why BE and ED are congruent to each other, because AC split them in half. So a segment bisector divides a segment into two congruent segments. AC split BD in half. And now BD also bisects segment AC. So BD did the same thing. It split AC perfectly in half. That's what a segment bisector does. Now, with saying angle BEC, why are these angles congruent? Well, they're right across from each other when these two lines cross. Those are called vertical angles. Vertical angles are always congruent. Why are these triangles congruent? Well, just like we did in the previous question, let's mark what we got. We've got a pair of sides, a pair of angles, a pair of sides. Side, angle, side. I guess that's why these are congruent. Side, angle, side. So then why would these segments be congruent? We said these triangles were congruent. And if we have triangles that are congruent, that means all their corresponding parts are congruent. So BC and AD are like the same side in each of the triangles. So they're corresponding parts, and corresponding parts of congruent triangles, they're congruent. Ta-da! All right, I believe we have two more of these questions. Yes, next problem. We are given that segment BE and BD are congruent to each other, that angle ABE is congruent to angle CBD, and we're trying to prove that ABC is an isosceles triangle. Trying to prove that ABC, the big giant triangle, is isosceles. What does isosceles mean? It means it's got angles here that are congruent to each other, and sides that are congruent to each other. So if we can prove either one of these things, either that the base angles are congruent or that the sides are congruent, then we will know that ABC is an isosceles triangle. So we had these segments were congruent to each other. I love how these light up, it's great. And these angles are congruent to each other up there at the top. Why would these angles that are lighting up, angle BED and BDE, be congruent to each other? Well, because this sucker in the middle is also an isosceles triangle. It has two congruent sides. So the angles across from those sides must be congruent because this is an isosceles triangle. It's got the defining characteristic of two sides that are the same. So we're looking for, in a triangle, angles opposite of congruent sides are congruent. Now, why would a BEA and BED be supplementary to each other? Well, they form a linear pair. If you add their bottoms together, they make a straight line all the way across. So these are a linear pair. If two angles form a linear pair, then they are supplementary. Just what that is, they're going to add up to 180 degrees, which is the exact same reason for the second one. If two angles form a linear pair, then they're supplementary. Okay, so then why are these angles congruent to each other? Well, they're both supplementary to angles that are congruent. So if, for example, just making up numbers here, if this was 30 degrees, then this would have to be 150 because they have to add to 180. And this angle is given to us that it's the same as the other one. So this one would also have to be 150. So since these angle BEA and BDC, the orange angles with the three lines, since they're both supplementary to congruent angles, they must be congruent to each other. If two angles are supplementary to congruent angles, then those angles are congruent. Okay, so then why are triangle AEB and CBD congruent to each other? Well, let's mark the things that we have for these guys. We now have a pair of angles that are congruent, a pair of sides that are congruent, and another pair of angles that are congruent. Angle, side, angle. That must be why these are congruent to each other. Angle, side, angle. So if triangles are congruent, that means all their corresponding parts are congruent, which is the reason segment AB and BC are congruent to each other. They are corresponding parts of now congruent triangles. So now why is the big triangle isosceles? Well, it's got two sides that are congruent to each other. It's got those two congruent sides. So it must be isosceles. The triangle has two congruent sides. Et voilà, c'est ça. Ça c'est tout. Très bien. Une autre. Okay. Next and final question. All right, we are given that BD and AC bisect each other. We remember that means they split each other in half. And we're going to try to prove that these lines are parallel to each other. Okay. Usually, when we're trying to prove lines are parallel to each other, we're using the fact that if we have alternate interior angles congruent to each other, then the lines must be parallel. If these angles on the inside of the Z are congruent to each other, then the lines must be parallel. Or we could have gone the other direction. If these angles over here on the inside of this other Z, if those are congruent to each other, then the lines must be parallel. So that's probably where this is going to go. Well, let's back it up. What were we given? We were given some bisectors. BD splits AC in half, which is what's happening here, that these halves are congruent to each other. So a segment bisector divides a segment into two congruent segments. That's what a segment bisector does. And similarly, AC split BD in half. So its halves are equal to each other. Segment bisector splits a segment into two congruent segments. Now, why are these angles congruent to each other? They're across from each other when two lines cross. So these are called vertical angles, and vertical angles are congruent. Now, why would these triangles be congruent? Why, oh why, oh why? Well, let's mark what we have. We got a side and an angle and a side. So these are some sassy triangles. Sassy, sassy triangles. And now why would parts of those triangles be congruent? Why are angle A and angle C congruent to each other? Well, they're corresponding parts of these now congruent triangles. And corresponding parts of congruent triangles are congruent. And what do you know? We've got the inside of the Z angles congruent to each other. Boom, boom. Those are called alternate interior angles. And when alternate interior angles are congruent, then the lines must be parallel. The two lines are cut by a transversal and form congruent alternate interior angles, then the two lines are parallel. Submit. Boom, bam. All right, scholars, those were all the questions for 4.4 AIP. Hope you had a great time and get yourself some points. Call me with your questions. Keep on the hustle.